Welcome back. We're in chapter 6, and in this chapter we're going to discuss experimental control. So we've been talking about a lot of different ways that we could go awry in scientific reasoning, and one of the ways that we can correct those problems is through gaining control. So let's talk a little bit about that. So first off, I'm going to just introduce the concepts that I'm going to be covering in this chapter. And they are all part of experimental design. So first off, we have to consider our participants. Where are we going to recruit them? How are we going to decide who's going to participate? Things like that. Now, there are different ways to go about recruiting participants. Here we have two different ways of recruiting participants. We have opt-out recruitment and we have opt-in recruitment. Opt-out recruitment is a lot more common in like medical research, where you already have patients who are maybe using a product or treatment or something, and you ask them, can we use you in our study? And they have to say no to not be included. And so for a lot of times you end up with more participants because they don't even know that they're actually in a study. So for example, let's say you start off with 116 possible volunteers. They're calling them registrants here. So you have 116 possible registrants. And in opt-out recruitment, you end up with 105 of them not opting out. They have not said no. You have only 8 who actually withdrew and said, I don't want to be part of your study. And then you have 3 who actually ended up being excluded for different reasons. Compare that to when you have to opt in. You have to say, I want to be in this study. So now out of 116 registrants, only 40 of them agree to participate, and 65 of them either never say anything or overtly say, no, thank you. Out of that 40, those 40 respondents who said yes, we still have those 3 invalid respondents that we would expect through, exclusion. So we're left with only 37 participants who we can actually use. So when we have opt-in recruitment, it's a lot more challenging to get a good sample. And that's how most psychological studies are conducted, is through opt-in recruitment, where participants have to say they want to do it. And in fact, might even have to go somewhere to participate or something like that. Now, I've done both types, frankly. I do a lot of research on teaching techniques. I do a lot of research on memory, and a lot of times I don't want my participants to know that I'm going to give a follow-up study. So what I'll oftentimes do is use students in the classroom. And so you're sitting in the classroom and I say, okay, so I want to do a study. We're going to be collecting some actual data for a study, and you do not have to participate. In fact, the last memory study that I did, I told students, you don't even have to say you don't want to participate. Just sit there with the materials. You could doodle on them if you wish. You don't have to do it. And then just turn them in with everybody else. I didn't have a single person who just doodled on their paper. Everybody at least somewhat participated. And so now I had some who ended up having to be excluded because they didn't participate fully, but I had almost everybody in that kind of opt-in situation. Every single person was intending to opt in. Like, nobody said no. So I ended up with way more participants than when I had done the exact same study in the lab, and people had to sign up and come there. And, it was a lot harder to do opt-in recruitment. Generally in psychology, participants have to opt in. We say, would you like to do this? They say, okay. And then they have to fill out a survey, or they have to come to the lab or do something like that. So typically we're looking at that harder to recruit kind of scenario where it's opt-in. Once we have participants who have opted in or are part of the study, now we have to decide how we're going to assign them to groups. Here's an example, again, from medicine, where we're going to be looking at, let's say there are 10 children who have registered to possibly be in the study. We could randomly select from that group of 10, our 4 participants. This is not a very good N in our study at all, but we're just doing it because it's easy to manipulate these numbers. So we've got 10 children in the population. We need 4. So we can randomly select 4 of them out of the population and then randomly assign 2 of them to the experimental group and 2 of them to the control group. right? So notice I used the word randomly twice. We randomly selected from the group that was willing to participate, the number that we actually needed. And then we randomly assigned from that sample into the different conditions. Random is really important in experimental designing. We'll get to that a little bit later. Variables. Okay, so this is just an overview. I will talk about each of these types of variables in a lot more detail later. But when we are designing a study, we have to identify what is the independent variable, the thing we're going to control or that we're going to hold steady. And then what is the dependent variable, the thing that we're going to measure. So first off, we have to figure out what those are. We have to identify them. And then we have to figure out a way to control, especially the independent variable. We have to figure out a way to make sure that the participants are only experiencing what we want them to experience. So a lot of effort's going to go into this part of the experimental design, and we will talk about it a lot later in this segment or in this chapter. The next big thing is to collect the data, right? And a lot of times when I have students working on their own project in my lab, whether it's a grad student or an undergrad, a lot of times they really want to get to the data collection. They really want to, get their hands dirty, get into the lab and actually start collecting data. And they kind of want to skip over the details of the participants and the details of the variables, but really we need to put a lot of effort into the, selection and assignment of participants and then identifying and controlling the variables so that when we collect our data, we can be sure that our data is representing what we expect it to be representing. We've talked in this class already about reliability and validity of our measures. So we want to make sure that we're using reliable measures and valid measures. And then ultimately, once we've got our data collected, the final thing to do is to analyze that data and find out what that pattern is really representing. I have a little joke I wanted to share with you about that. So Dr. Grant is saying, this will take just a minute. What test do I use? He should not be sitting there with a whole bunch of results on his desk, like the little cartoon is implying he has, trying now to figure out what statistical test he's going to use to analyze that data. You need to actually deliberately set up your data collection so that you end up with the kinds of data that would be analyzable with the correct kind of statistic. Like you have to plan that out in advance. And in fact, one of the big debates in psychology is whether you should be taking a research methods class first or you should be taking a statistics class first. Because a lot of people argue you can't really design a good study if you don't know what statistics are available or which ones would make sense for what kind of data. We all make mistakes sometimes. Like, for example, I was collecting information about the age of my participants with just the intention of describing that in my demographics. And then once I collected my data, I realized I had a wide variety of ages in my sample. And maybe it would have been interesting to use that as a variable in a correlation to see whether older participants are giving different answers than younger participants on the survey that I was using. Now, what I'm describing is not an experiment, but it's a good example of I could not do the analysis that would have been really interesting because I had collected the age data incorrectly. I had just let them mark whether they were 18 to 25 or 26 to 40, and I had just broken it down basically on lifespan developmental stages of adulthood. And I thought that would be good because a lot of times students or respondents don't really want to tell you exactly what their age is. So I thought, well, this is good just for the demographics, just kind of describe what my sample looked like. But you can't use that kind of categorical data if you want to do a correlation. You have to have continuous data. And so I could not do the correlation that I wanted to do because I had collected the data wrong for that kind of analysis because I hadn't thought about it beforehand. I really hadn't considered the possibility that I would have enough variation in age that might end up being an important variable or a helpful variable. And I still don't know whether it was or not because I couldn't analyze it. So it's really super important when we're designing our experiments that we collect the kind of data that we need for the statistical test that we plan on running. And so we should never find ourselves with a pile of data on our desk going, okay, so now what should I do with this? All right. Basically, what I would like you guys to follow whenever you're thinking about research design, you want to follow the principle of KISS, which stands for keep it simple, stupid. So sorry, I didn't want to spell that out because it's kind of a rude statement. It's very common in like the military and other places where people will say, you know, follow the KISS principle, right? We in science like to call it the principle of parsimony or Occam's razor, as we discussed previously, right? We want to follow the simplest procedures. So you want to include as few variables as possible. While it's maybe interesting to design a study that would have a bunch of variables and you feel like you're really going to be able to know what the pattern is, fewer variables is actually better. For one thing, if I'd known they wanted me to use all this information, I would never have asked for it, because one of the things that happens when you have lots of variables is that at the end, on the back end, the statistical analyses are so complicated and so tedious. I'll just say it, it's tedious when you have lots of variables to try and explain what they all did. It's just tedious. And you realize I already answered my question with the first 2 variables, and why am I still explaining these other 5 variables that I now regret having collected the data on? So as few variables as you possibly can collect and still answer your question is really the goal. So following the principle of parsimony, I wanted to show you this example from an actual study where the researchers used 4 different independent variables. I blurred out these numbers and things in this table so that you wouldn't be distracted by that and wondering what those statistical notations mean. I just wanted you to focus on the source of variation. So they've got 4 variables that they've named here: parenting style, school performance, sex, and age, that they're going to each treat as independent variables. So when we do an analysis, we treat each of those independent variables as a separate variable that can be assessed just by itself. What amount of the performance on the dependent variable could be attributed to parenting styles? What amount of it can be attributed to school performance or to sex or to age? Those are what we call main effects, when we're just looking at those independent variables one by one and looking at the effect on the dependent variable. Then we can start looking for interactions of variables. So we look at, they've listed it here as A by B. So that means that we're looking for the interaction of parenting style and school performance on the dependent variable. So what we're looking for is whether people with different having been parented in different parenting styles and who have displayed different levels of school performance perform differently on the dependent variable from one another. So we can look at parenting style by school performance. We can look at parenting style by sex, parenting style by age. Then we get down to the B variable. Now it's school performance by sex, school performance by age, and then we look at the sex by age interaction. So those are all what we call two-way interactions. Then we get down to the three-way interactions. And so now we're going to look at the confluence of parenting style, school performance, and sex, parenting style, school performance, and age, parenting style, sex, and age, school performance, sex, and age. That concludes all of the three-way combinations that we could create. And then finally, we have putting all those independent variables into one big analysis to see what impact these four variables have as a group. So now we want to see whether people with certain parenting styles, I can't say parenting styles, it's really hard. So whether people with certain parenting styles and certain school performance levels and one sex or the other and their age are different from people who have a different parenting style, a different school performance, the other sex, a different age, right? So we end up with all these possibly very nuanced, groupings that we could end up with. And this is at the bottom there, that four-way interaction. Four-way interactions are very difficult to interpret, but I just wanted to sort of show you that when it doesn't seem like that big of a deal to have four variables, does it? Four variables doesn't seem like too much at all until you see it mapped out like this and you realize you have to consider each of them as individual factors that could contribute to the dependent variable, each of them combined with one other of the variables 3 of them combined together, and then all 4 of them combined together. So when you add additional variables, you add enormous complexity. The simpler you can keep it, the better off you're going to be. So that's the basic message I would like to leave you with, is keep it simple. Follow that principle of parsimony. That's the goal. All right. So let's stop here, and we will come back in the next segment and we will talk about the nature of variables.